Hi friends, welcome back. So today we have another set, that is CS ISRO 2014 paper, right? We have done lots of previous year question paper. Hope this series is also helping you, right? So let's start with this question paper as well. Now the very first question is, consider a 33 megahertz CPU based system. What is the number of wait state required if it is interfaced with a 60 nanosecond memory? Assume a maximum of 10 nanosecond delay for addition circuitry like buffering and decoding. So if you solve this question, you will get the answer as 3, that is option D. So basically a wait state is the delay experienced by a computer processor when accessing external memory or another device that is slow to response. So total memory access time, that would be 60 nanoseconds plus 10 nanosecond, that is equals to 70 nanosecond, right? So this particular question, you will get the answer as A, that is 14. Right here you can see that we have this hash defined sqrt sqr x into x. So from here we will pass the value, right? So what will happen, here you can see that int a equals to int a, then int b equals to 4. Now a sqr b plus 2. So in this sqr, this is taking x, that is b plus 2, that means 4 plus 2 is equal to 6. Okay, and it is asking that x into x. So basically the value of x is b plus 2. So here b plus 2 into b plus 2, that will be nothing but 4 plus 2 into 4 plus 2. So here 4 plus 2 you will get 6, and multiplied by 4 plus 2 you will get 6. I mean, if you solve that expression using the BODMAS, right, that you will have 4 plus 2 into 4 plus 2. So first you will solve 2 into 4, that is 8. Then you will add 8 plus 4 is 12, and 12 plus 2 is 14. So A will be our answer. Now question number 4 is, consider the following pseudocode, right? This is the program. What is the cyclomatic complexity of the above pseudocode? So here it is asking for the cyclomatic complexity. So if you solve this, you will get the answer as 4. Basically what you can do is you can make a control flow graph CFG for this pseudocode, right? And now for the cyclomatic complexity, first you will see the number of edges minus number of nodes plus 1, right? That is the formula. And in this way, if you draw this, you will get the answer as 4, right? Now question number 5 is, what is the number of steps required to derive the string? This one for the following grammar, right? So we have to derive the string. So now we have to find the step that are required. So if you solve this particular question, you will get the answer as A, that is 10, right? Like to generate this, you will have to frame the grammar. Okay, like from S you will first call open parenthesis S and close parenthesis, then again for S you can call SS, right? So from 1S you will get again this open parenthesis inside S, and so on so forth. You will have 10 steps to solve this, right? Now next question is, the process of modifying IP address information in IP packet header while in transit across a traffic routing device is called what? So for 6 our answer will be B, that is the network address translation, NAT. So the process of modifying IP address information in IP packet header while in transit across a traffic routing device is called network address translation, that is NAT. So basically network address translation or NAT is a method of remapping one IP address space into another by modifying network address information in the IP header of packets while they are in transit across a traffic routing device, right? So port address translation PAT is an extension to a network address translation NAT that permits multiple devices on a local area network LAN to be mapped to a single public IP address, right? So the goal of PAT is to conserve IP addresses. So address mapping, also known as pin mapping or geocoding, as the process of accessing map coordinate location to addresses in a database. The output of address mapping is a point layer attribute with all of the data from the input database. Port mapping or port forwarding is an application of network address translation, or NAT. Now question number 7 is, what does a pixel mask mean? So basically a pixel mask mean is nothing but a string containing ones and zero, right? Pixel mask a pixel mask is a string containing ones and zero. So pixel counts for the span length and inter-span spacing can be specified in a pixel mask, which is a string containing the digit 1 and 0 to indicate which position to plot along the line path. So the mask, let's say 111 000 for instance, could be used to display dashed line with a dashed length of 4 pixel and an interdash spacing of 3 pixels. So basically, yeah, the answer is D. That is the pixel mask mean is the string containing ones and zero. Now question number 8 is, in the standard IEEE 754 single precision floating point representation, there is 1 bit for sign, 23 bit for fraction and 8 bit for exponent. What is the precision in terms of the number of decimal digit? So for question number 8, if you solve this, you will get the answer as C, that is 7, right? So in that standard IEEE 754 single precision floating point representation, there is 1 bit for sign, 23 bits for fraction and 8 bit for exponent. So 7 is the precision in terms of the number of decimal digit. So basically precision can be understood as the maximum accuracy through which a floating point number can be represented, right? So it is the smallest change that can be represented in floating point representation, and the functional part of a single precision normalized number has exactly 23 bits of resolution, right? So 24 bit with the implied bit, that is in terms of decimal representation. Okay, so here the answer will be 7 if you get that. Now question number 9 is, let R be the radius of circle. What is the angle subtended by an arc of length R at the center of the circle? So for question number 9, our answer will be A, that is, sorry, answer will be B, that is 1 radian. So let R be the radius of circle. What is the angle subtended by an arc of length R at the center of the circle? So for this, answer will be B, that is 1 radian, right? Basically radian describe the plane angle subtended by a circular arc as the length of the arc divided by the radius of the arc, right? So 1 radian is the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. Now question number 10 is, the number of logical CPUs in a computer having 2 physical quad core chips with hyper threading enable is what? So for question number 10, our answer will be 16, right? So 16 will be the answer, that every physical CPU corresponds to 2 logical CPU in hyper threading, and there are 2 quad core chips. So therefore total number of physical CPUs equals to 2 into 4, that is 8, and now 8 physical CPU correspond to 2 into 8, so you will get 16 logical CPU. But here one important thing is that a multi-core processor is a single piece of hardware, right? So one processor that provides several cores then that can work concurrently. Okay, so yeah, for this the answer will be D. Now let's continue with the next question, that is 11, that an aggregation association is drawn using which symbol? So for this our answer is B, that is a small open diamond at the end of line connecting 2 tables. So B will be the answer, a small open diamond at the end of line connecting 2 tables. I hope you remember that association is a relationship where all objects have their own life cycle and there is no owner, right? Whereas aggregation is the specialized form of association where all the objects have their own life cycle, that there is but there is ownership and child object cannot belong to another parent object, right? Whereas composition is the again specialized form of aggregation, and we can call this as death relationship. So for this here the answer is B, like an aggregation association is drawn using with symbols. So a small open diamond, remember that this is open diamond at the end of line connecting two tables. Now question number 12 is how many states are there in a minimum state deterministic finite automation accepting the language. This one, number of zeros is divisible by 2 and number of ones is divisible by 5 respectively. So for question number 12, if you solve this you will get the answer as C, that is 10, right? So you can create minimal DFA, right, deterministic finite automata, and try to run this language and you will get these state. Now next question is which of the following is true with respect to a reference. So with respect to a reference, that a reference can never be null, right? Always remember that a reference cannot be null, because whereas pointer can be null but a reference cannot be null, because every reference refers to some object, like, right, although it may or may not be valid, a reference can never be reassigned once it is established. So option A will be correct. A reference can never be null while a pointer can be. Now question number 14 is there are 200 tracks on a disk platter and the pending request have come on the order these one, right? Assume the arm is located at the 100th track and moving toward track 200. If sequence of disk access is these and 76, then which disk access scheduling policy is used? So for 14 our answer will be C, that is C scan, right? So C scan will be the answer for this particular options. Question number 15 is consider the logic circuit given below, right? Now what is the value of Q? So here if you solve this you will get the answer as C, that is AB, B C bar and B D bar. How? Look here, from here you will get D C bar, right? That is D bar C bar, okay, and from here you will get D bar C bar and B bar. So you will get C D complement, B of whole complement, right? And from here you will get AB complement. So at the last what you will get, you will get at the last, once you will solve that you will get the answer as C, that is AB plus BC bar plus BD bar. Now question number 16 is what is the routing algorithm used by OSPF routing protocols, right? So the routing algorithm, that is a link state that is used by OSPF routing protocol. Basically OSPF is nothing but here it is open shortest path first. So this is a link state routing protocol, right, which is a network layer protocol and uses link state routing method to calculate the shortest route to a destination through a network based on an algorithm. It falls into the group of IGP, interior gateway protocol, right? So link state will be our answer for 16. Now question number 17 is if each address space represent 1 byte of storage space, how many address lines are needed to access RAM chips arranged in a 4 by 6 array and where each chips is 8K into 4 bits. So for question number 17, if you solve this you will get the answer as D, that is 17, right? So if each address space represent 1 byte of storage space, how many address link are needed to access RAM chips arranged in a 4 into 6 array where each chip is 8K into 4 bits. So this will probably give you 17, right? So if you solve this you will get the same one, and with the same method that we used to get, like size of each RAM chip will be 8K into 4 bits, right? So that will be 2 to the power 3 multiplied by 2 to the power 10 multiplied by 2 to the power 2, where you will get 2 to the power 15 bits, and which will equal to 2 to the power 12 byte number of chips required, right? So that way you will get this answer as 17. Now question number 18 is consider the following segment table in segmentation scheme, right? What happen if the logical address requested is segment ID 2 and offset 1000? So for this our answer will be B, that is a trap is generated. So what happen if the logical address requested is segment id 2 and offset 1000, segment id 2 and of 10,000. So here the trap is generated. Now question number 19 is the number of bits string of length 8 that will either start with 1 or end with 00 is what? So the number of bit string of length 8 that will start either with 1 or 00 will be 160, right? So 160 number of bit string of length 8 will start either with 0 and 1. Now question number 20 is which of the following is not maturity level as per capability maturity model? So here measurable is the answer. That is, a measurable is not a maturity level as per capability maturity model or CMM. So measurable is the answer here. Basically there are 5 levels of maturity capability maturity model, that is CMM. First is initial, then we have repeatable, right? Then we have defined, then we have managed or capable, we can say. Then the fifth is the optimized, but measurable is not the level in that model. Now question number 21 is consider the following sequential circuit. What are the value of Q0 and Q1 after 4 clock cycle if the initial value are 00? So for this again our answer will be 00. If the initial value is 00 after 4 cycle, this the answer you will also get as 00. So you can quickly run this as well, and the value of Q0 will be 0 and Q1 will be 1. Question number 22 is consider the schema relation this and the functional dependency A tends to B and C tends to B. If the decomposition is made as R1AB and R2CD, then which of the following is true? So for 22, if you solve this, you will get the answer as A, that is preserves dependency but cannot perform lossless join. Remember this, this preserve dependency but cannot perform lossless join. Because here it is asking that the schema and functional dependency is A to B and C to D. If the decomposition is made as R1AB and R2CD, then preserve dependency but cannot perform lossless join. Because hope you remember that to check for dependency preserving, a decomposition is said to be basically dependency preserving if F closure will be F1 union F2 union up to the Fn closure, right? Where F closure total function dependency FDs on universal relation R and F1 set of functional dependency of R1 R2 that will be equals to set of functional dependency of R2, and so on so forth. The process will keep going, right? So yeah, here A will be the answer, that preserves dependency but cannot perform lossless join. Question number 23 is the test suite set of test input used to perform unit testing on a module could cover 70% of the code. What is the reliability of the module if the probability of success is 0.95 during above testing? So for 23 our answer will be B, that is at most 0.665. So this will be the answer, because the reliability is basically equals to coverage multiplied by probability of success, right? So here you will get 0.7, that is 70%, multiplied by 0.95, so which will give you 0.665. so at most it will be 0.665. Question number 24 is in a system on RSA algorithm with P equals to 5 and Q equals to 11 is implemented for data security. What is the value of the decryption key if the value of the encryption key is 27? So for question number 24 our answer will be 3, right? 3 will be the answer here. Now question number 25 is suppose you want to build a memory with 4-byte word and a capacity of 2 to the power 21 bits. What is the type of decoder required if the memory is built using 2K into 8 RAM chips? So here if you solve this you will get the answer as A, that is 5 to 32. right? So option A will be the answer. Suppose you want to build a memory with 4 byte, right? What's the and capacity of 2 to the power 21 bits, which is type of decoder required of the memory is built using 2k into 8. So here 5 to 32. Question number 26 is the output of a tri-state buffer when the enable input is 0 is what? So for this the output will be disconnected state, right? So the disconnected state will be the output of a tri-state buffer when the enable input is 0, right? Now question number 27 is how many different BCD number can be stored in 12 switches? Assume two position or on off switches. So here the answer will be 10 to the power 3. So 10 to the power 3 different BCD number can be stored in 12 switches, right? So option D will be the answer, 10 to the power 3. Question number 28 is suppose there are 11 items in a sorted order in an array. How many searches are required on the average if binary search is employed and all searches are successful in finding the item? So for 28, if you solve this, you will get the answer as A, that is 3.0, right? So A will be the answer here. Now question number 29 is consider the following Java code, right? Fragment. Which of the following statement is true? So here you can see this is the Java code fragment. Now if you read all these four options, the D1 is true, that is there is a syntax error in line 6. So here you can see basically what happens. Java is a case sensitive, right? Always remember that. So while is a valid class name as shown in the line 1. Okay, you can see that this is while, right? Because class name always start with capital letters. So option 1, it is saying that there is a syntax error in line 1, that will be false, right? An equation may be placed in a string operating is valid as shown in line 8, right here. So option C, you can also see that there is syntax error in line number 8. This is also false, right? We are eliminating. Now using the integer 1 and in the while statement or any other looping construct for the matter will result in a compiler error. This is old C program, not valid Java as shown in line 6, right? So while inside one will populate an error, so that will be a syntax error in line number 6. Question number 30 is every time the attribute A appears, it is matched with the same value of attribute B, but not the same value of attribute C. Which of the following is true? So for 30, our answer will be B, that is A, B and A, C. Question number 31 is asking that a IP packet has arrived in which the fragmentation offset value is 100, the value of hlen is 5 and the value of total length field is 200, right? So what is the number of the least byte? So if you solve this, you will get the answer as C, that is 979. Okay. Question number 32 is what is the output of the following C program? So this is the program, and if you hit and try or play with the program, you will get the answer as D, that is the value of Shifty is 2700. So this will be the answer. The value of Shifty will be 2700 because here you can see this is basically shifting bits, right? So we can say binary shifts are having doing here. Question number 33 is the following finite automation recognition which of the following language? So here you have to find the language accepted by the finite automation. So let's start with the one by one. 1 0. Okay, either 1 or 0, right? Or this could be nothing. Okay, if this is having okay, then if it is not having okay, any time of 0 having is also okay, and any time of 1 having is also okay, but it is ending with 0 1, right? So minimum requirement is 0 1. So here you can see this is meeting the condition, so A will be our answer here. Now question number 34 is how much memory is required to implement Z buffer algorithm for 512 into 512 into 24 bit planning image. So for 34 our answer will be C, that is 1.5 MB is required for that. Question number 35 is using the page tables shown below. Translate the physical address 25 to virtual address. The address length is 16-bit and page size is 2048 words, while the size of the physical memory is 4 frame. So in that case, for 35, if you solve this, you will get the answer as D, that is 4121. 36 is consider a standard circular Q implementation which has same condition for Q full and Q empty, whose size is 11 and the element of the Q are Q0, Q1 up to Q10. The front and rear pointer are initialized to point at Q2. In which position will the ninth element be added? So for 36, our answer will be A, that is Q0, right? Now, next question is the probability that two friends are born in the same month is what? So for 37, our answer will be B, that is 1 by 12. So the probability that two friends are born in the same month is 1 by 12. For 38, how many lines of output does the following C code produces? So if you solve this particular question, you will get the answer as 11, that is option D. So this will be our answer. Now question number 39 is it is asking if only one memory location is to be reserved for a class variable, no matter how many objects are instantiated, then the variable should be declared as what? So for 39, our answer will be B, that is static. So if only one memory location is to be reserved for a class variable, no matter how many objects are initiated, then the variable should be declared as static. So next question is question number 40. Assume that a 16-bit CPU is trying to access a double word starting at an odd address. How many memory operations are required to access the data? So for 40, if you solve this, you will get the answer as C, that is 3. Next question is question number 41. Consider the following binary search tree given below, which node contain the fourth smallest element in T. So it is asking about fourth smallest element in T. So if you solve this, you will get the answer as W. Now question number 42 is let X, Y, Z, A, B, C be the attribute of entity. These are a super key. Then which of the following are the candidate key? So for 42, our answer will be B, that is X and AB, right? 43 is the 5 items A, B, C, D, E and E are pushed in a stack one after the another starting from A. The stack is popped up for 4 times and each element is inserted in a queue. Then 2 elements are deleted from the queue and pushed back in on the stack. Now one item is popped from the stack, so the popped item is what? So for 43, if you solve this, you will get the answer as D, that is D itself. Question number 44 is a computer has 16 page of virtual address space, but the size of main memory is only 4 frames. Initially the memory is empty. A program references the virtual page in the order these. How many pages faults occurs if LRU page replacement algorithm is used? So for 44, if you solve this, you will get the answer as 7, that is option number C. Question number 45 is consider a 50 kbps satellite channel with a 500 milliseconds round trip propagation delay. If the sender wants to transmit 1000 bit frames, how much time will it take for the receiver to receive the frame? So for 45, our answer will be D, that is 270 milliseconds. Now 46 is if the maximum output voltage of a DAC is V volt and if the resolution is R bits, then the weight of the most significant bit is what? So for 46, our answer will be B, that is 2 to the power R minus 1 V divided by 2 to the power R minus 1. 47 is the following 3C language segment is equivalent to which single statement? So for 47, if you solve this, you will get the answer as B, that is Z equal to X plus plus Y. So B will be the answer here. 48 is a frame buffer array is addressed in a row mirror order for a monitor with pixel location starting from 00 and ending with 100. What is address of the pixel? 6 to 10. Assume 1 bit storage per pixel and starting pixel location is at 0. Right. So for 48, if you solve this, you will get the answer as A, that is 1016. 49 is consider a single linkage list where F and L are pointers to the first and last element respectively of the linked list. So the time for performing which of the given operation depends on the length of the linked list. So here for 49 our answer will be C, that is delete the last element at the list, right? So C will be the answer. Now 50 is let A be a finite set having X element and let B be a finite set having Y element. What is the number of distinct function mapping B into A? So for 50 our answer will be A, that is X to the power Y. So yeah friend, let's wrap up this video at the question 50, right? This is the part 1 as. So in the part 2 we will cover from 51 to the other question, right? So stay tuned. All the best.